Hey guys, so let's go through an example from class today. I was talking in class about converting from one unit to another using the metric system. And we talked about this chart where we have from tera all the way down to pico. In the middle, we have our base units, and we have all these powers of 10 that separate them. I put it on a scale so each line equals 1 power of 10. And so if I'm going from mega to 1000 to kilo, that's 1000 because it's 3 units of 10. And so I thought this was a really good idea. I saw somebody doing it in 7th period and it worked out pretty well, I thought. So here's our scale, and we have certain steps. The first steps we need to do is convert whatever number we're given in the problem into scientific notation. Once we have it in scientific notation, then we're going to come over to our number line and we're going to subtract the exponents. We're going to take the bigger one minus the smaller one, and that will be the exponent for our equality. And when we write our equality, it'll be 1 of the big unit, so the one that's higher up on this chart, equals 1 times 10 to whatever we got in part 2 for the smaller unit. And then we can use this equality to set up and solve our problem using dimensional analysis. So let's try this problem. Example 1. Convert 3,900 milliliters to kiloliters. So I first need to convert that into scientific notation. So that's going to be 3.9 times 10 to the 1, 2, 3, positive 3. And that's still milliliters. Now, second step, go to the bigger unit and subtract the smaller unit of the exponents. So here's kilo, which is 3. I'm going to use a different color of ink so you can see what I'm doing. And so it's going to be 3 minus, and our smaller unit is milliliters, and it's down here, so that's minus a negative 3. And so that comes out to 6. So our equality that we're going to write is that 1 kiloliter, I got that from right here, that's my big unit, equals 1 times 10 to the 6th of my smaller unit, which is milliliters. Now I need to set it up using dimensional analysis. So going back to the blue pen, we have 3.9 times 10 to the 3rd milliliters times, and I need milliliters to cancel, so this term will go in the denominator. It's going to be 1 times 10 to the 6th milliliters, and 1 kiloliter goes in the top. This is the unit I want to end up in, and I want this one cancel out. So now, since this is in the numerator, I'm going to get 3.9 times 10, and I'm going to take 3 minus 6. My unit is kiloliters. So my final answer, well, you can't quite see that, can you? Sorry about that. I'll move this up here. So my final answer is going to, when I subtract 3 minus 6, I get 3.9 times 10 to the negative 3 kiloliters. And that's the final answer. So why don't we do a second example? So, example 2. Let's convert 1.9 megagrams to micrograms. So the first thing I do is put it in scientific notation. So that's going to be 1.0 times 10 to the 0. That's going to be megagrams. Next thing I need to do is find my 2 exponents and subtract them. So let me move this out of the way. And so we want to go from mega to micro. We always subtract the bigger from the littler, or I mean the big one minus the little one. And so I'm going to have 6 minus a negative 6, which equals 12. And so we're going to have 1 megagram equals 1 times 10 to the 12th microgram. grams. So now to set up my problem, using dimensional analysis, I'm going to start with 1.0 times 10 to the 0 megagrams times, I need 1 megagram here for 1 times 10 to the 12th micrograms. Megagrams cancels out, and I get 1.9 times 10 to the 0 plus 12, because when it's in the numerator or we're multiplying, we add the exponents. When we're dividing, we subtract. And so this is going to equal 1.9 times 10 to the 12th micrograms. So let's look at our two examples side by side. In example 1, we went from a small unit, millis down here, to a big unit, killies up here, and our number went from being fairly big to fairly small. Here we went from megagrams, which is up here, to micrograms, which is down here, and our number got very big, which is what we expect when we go from a big unit to a small unit. So if we go to a big unit to a small unit, the number gets bigger, right? But if we go from I'm not sure I can get this on the screen, if we go from a small unit to a big unit, what's going to happen to our number? Our number gets smaller. And so an example of a big unit to a small unit would be like example 2, and our number got bigger. And on the first example, we went from a small unit to a big unit, and so our number got smaller. Negative exponent means it's a smaller number. I hope this helps. Let me know if you need anything else. Have a good weekend.